Hi, this is Professor Stugard, and in this video we're going to talk about how we wrangle our data. So in this video lecture, which is going to be a little bit longer than some of the other ones because we're going to cover quite a bit, we're going to learn how we can take our data frame and using some functions, how we can learn to specifically choose what columns and what rows we want from a data frame, how we can add rows and columns to our data frame, and also how we can modify our data frame and then save that modified data frame for later use. We're going to finish up by figuring out how we can create some summary statistics from our database as well. So when we're wrangling our data, again, typically we have these large data sets with lots of variables, lots of observations, and what we want to do is actually just select a few of those at a time. We don't want to necessarily look at the entire data set because there's just a ton of data in our data set. We want to try to filter it down and select what it is we want to use. Now, the most important functions to be able to do this are in what's called the dplyr package. And so we're going to use those functions combined with our piping function, which we discussed last week, to figure out how we can wrangle and arrange our data. All right, so again, when we say wrangling, what we really mean is we're trying to clean up our data for analysis. So we do the wrangling first, and then that's going to be how we organize and structure our data frame so that we can hopefully make our graphics and make our summaries as easily as possible. So that dplyr package is part of tidyverse, and again, we're pretty much going to load tidyverse as the first thing we do in every one of our programs, so you don't necessarily have to load it separately. They'll all be there for us to use once tidyverse is installed and loaded. Now, a few things to keep in mind with each of the functions we're going to discuss today. The first thing is that, well, each argument in the function needs to be the data frame, that first argument. So the first thing inside my parentheses needs to be my data frame, or we need to pipe the data into that function. All right. Either way, it's got to start with my data frame. So either, again, we choose our function, and one of the functions we're going to talk about in this lecture is the select function. And if we use the select function, again, the first thing in our parentheses has got to be our data frame, then a comma, and then the rest. Or if we do the piping feature, which again is kind of my preferred way to do it anyway, we take our data frame and we're going to pipe it into our select function, and then again inside the select function, then we'll actually make our choices about how we're going to select things. Now, the second thing we want to keep in mind when we use these functions is that once we run this function, it's always going to return another data frame. Our output is going to be another data frame for us. So the idea is we're going to input a data frame, we're going to modify it in some way, and then we're going to have our output as that modified data frame. Now, again, our functions, we can add or remove columns or rows, we can rearrange and order and summarize. However, the output is always going to be in the form of a data frame itself. All right. Which means that, again, we might have to save that data frame. So the functions we're going to look at today are going to be filter, which is how we pick our observations in rows. So again, it's going to go through our whole data frame, and it's going to only pick certain rows or observations for us based on our criteria. There's select, which is only going to pick our variables or columns, again, based on our particular criteria. Then there is the arrange, which reorders our row in ascending order, so from smallest to biggest. And if we want to reorder in descending order, we do arrange in descending order and then put our information in there. And that's not the only way we can do it. And I'll even make a note of that formally towards the end. But that's typically the way that I like to write it out because it's just easier for me to read my code and know what it is I'm doing. Then we also have mutate, which allows us to create new variables and columns, and rbind, which lets me create new rows, or even lets me combine two separate data frames together. Then the last thing we're going to talk about is the summarize function, which is how we create our summary statistics. And again, we're basically going to collapse down tons of values to just one single summary, like finding the average of a bunch of numbers. All right, so as I said before, the original data frame is not going to change when we mutate it unless we actually save it again, right? We take our original data frame, we modify it, and then we have our modified data frame at the end. And we either have really three choices, I suppose. Either we don't save it and we just look at the modified data frame and we're like, okay, well, that was no good. There's no point in storing that anymore. Or we want to save it again. And so we can either save it as a brand new data frame, right? We can either create a brand new data frame where we would have, again, new data frame, and then we're going to store, right, in that new data frame. Well, we take our old data frame from what we started with, and we're going to pipe that into our functions, all right? So that's, again, if we want to store it brand new in a brand new data frame and still preserve the old one, right? This preserves the original data frame. That means that the original data frame is still going to be stored in that physical location in the memory, all right? And it's not going to be changed at all. And then we're going to create a separate spot called new data frame, and our modified one is going to be stored there. And we'll have both the original and the modified version both stored in computer's memory for us to access later. All right. Then again, we would pipe that into whatever my select function or whatever type of function it is we're going to do. All right, if I want to create a new one. Now, if I want to overwrite the old data frame, what I can do is just, well, take the name of that data frame, and I'm going to store it, right? I'm going to store it, but I'm going to take my original data frame. Right? I'm going to modify my data frame, and in this case, when I write it like this, I'm going to take my data frame, I'm going to modify it, and then I'm going to store it right back in that same physical location in the memory. When I do this, the original data frame is gone. We can't ever get it back. The computer did not save it. It's gone. It's been overwritten. And again, sometimes that's nice because we don't need all that extra stuff for the analysis we're going to do, so there's no problem. And again, it kind of just depends on a situational basis on whether we want to save a brand new data frame or just overwrite the old data frame, or if we even want to save it at all. So let's jump right into our different types of functions. So that first one is the filter function, and this allows us to choose only specific rows or observations from our data frame. So again, we're basically going to look through our entire data frame, the whole thing, and we're going to filter and just pick the certain rows that we want based on our criteria, right? Based on our conditions. So we're going to take our data frame, we're going to pipe it in to filter, and again, right, filter is choosing the observations or the rows, but again, to choose which rows we want, there needs to be some criteria for one of our columns, right? There's got to be a value for one of our columns that lets us select those specific rows. And we want to, again, kind of set this up as a logical operator. The column is equal to whatever that particular value is. And again, it could be a number, it could be a name, and again, we could also use our other relational operators. We could use less than or greater than or equal to or not equal to. Again, we can filter in using any of those different types of operators here. And we can also, what's nice, is use a negative sign to remove specific rows. So if I want to filter and I want to get rid of everything based on a certain criteria, I can actually use a negative sign in front to do that for me. So I think the easiest way to kind of show how these functions are all going to work, let's start with a very simple data frame that's just about pets. And this is it. This is the whole data frame. We have the variables owner of the pet's name, its species, its breed, its sex, its weight in pounds, and its height in inches. So we have 7 variables in our data frame, and it looks like we have 5 observations, right, where the owner is Tom, Amanda, Adam, Brittany, and John. We have a mix of cats and dogs, and then of course we have their breeds, their sex, their weight, and their height. So this is the data frame we're going to be starting with. Notice, however, that we do have one entry where it is capital N, capital A. All right. Any entry that is marked NA, that means there's actually no data in that entry. That is a blank cell. There's no actual data there for us. So we don't know what breed John's cat Cole is. It just was never filled in. That data is missing. And again, we're going to run into a lot of missing data throughout this course. You're going to run into a lot of missing data with every data set you probably try to look at. And then you're going to have to also decide, well, what's appropriate to do with the missing data? Can I still include that observation? Should I get rid of it? What do I do with it? And again, it'll be a case-by-case kind of situational basis. But again, anytime you see an NA, that means there's just no data there. All right. Now let's say I have that data frame of all the pets, and I only want to look at the observations that have dogs. I only want to look at the dogs here. So the way I'm going to do this is I'm going to take my data frame pets, and I'm going to pipe it in. Again, I love that piping feature, right? I'm going to pipe it into my filter function, and I'm going to filter based on the species being equal to dog. So again, the column name, we don't need quotes around because that's the name of the column. We know that we're looking at the column, but because this column is made up of strings of characters, their names, they have to be in quotes. All right, and again, you might get a little confused, might make some mistakes in the beginning, but it's one of those things that the more you practice and the more you write code, it just becomes second nature and you stop making those sorts of mistakes, really. But again, it's all just practice and playing around with it. So if I were to run this code, right, if I'm going to filter and I'm only going to choose my rows and observations where the species is equal to dog, this is what it's going to return. So now I got rid of every entry that was not a dog, got rid of all the cats, and now my data frame is only those 3 observations. I've selected for just those 3 observations. And that's what the filter function does for me. All right, like I said, use the quotes with the entry names. Now, the nice part is I can actually filter based on multiple criteria. So let's say I want the observations and I only want dogs that weigh more than 20 pounds. Well, now I can use my logical operators and my comparison operators as well to filter for both of those criteria. Here's how I would do that. So again, start with my data frame pets. I'm going to pipe that into my function. My function is filter, and so I'm going to filter, again, the species has to equal dogs, or species equals dogs. And I need it to be both, that's my and, I want it to be both, and I want the weight in pounds, right, that other variable, that other column, to be greater than 20. So again, like I said, we can use our comparison operators here as well. And because 20 is a number, it's not a string of values, it's not a name, we do not need any quotes. We want to keep it as that number. And if I run my code now, well, it's going to select for just those 2 entries where the person has a dog and the dog is larger than 20 pounds. So again, that's how filter works. And again, we can select only the observations we want, and then from here we can do whatever other sort of analysis we might want to. Now, if I want to, again, retain that modified data frame for later use, if I do want to end up maybe making a graphic out of it, I do want to save it and store it into memory. So again, it's a good idea to make sure you pick a descriptive name for your data frames that you're saving, and a descriptive name actually for any variable that you want to save. Pick a nice descriptive identifier for it. So in this case, I want to save my new data frame as heavy dogs. Again, I'm going to use my underscore between the word heavy and dogs. And again, heavy dogs, that's where everything is being stored. I have my arrow saying it's being stored. I'm starting with my original data frame pets, which I'm piping into my filter function based upon those 2 criteria. All right. So again, that's how I would store a brand new data frame here in place. Now let's take a look at the next function. Now select is how we can choose our specific columns or our specific variables that we want to either retain or remove from our data frame. To remove them, we're just going to use a negative in front of the name itself. All right, so again, let's kind of jump into our example. Our data frame pets, we're going to use that same data frame for every example in this video. And let's say I only want to know the owner's name, the pet's name, the species, and the sex. I don't need the height, the weight, the breed, that sort of stuff. I only want those things. Well, again, I start with my data frame pets. I'm going to pipe that into now my select function, and I want to select, well, those columns. And I'm going to separate each one with a comma as always. So the owner, comma, the pet name, comma, the species, comma, the sex, comma. And if I do that, the data frame that's going to be returned is, well, my original data frame with the 5 entries and the 5 rows. But now I'm only looking at that data where I have the owner, the pet name, the species, and the sex. Now, I could, again, like I said, do this in reverse. If I were to do this, and let's say we do not want the breed, the weight, or the height included. So again, it's the same idea, but now I'm reframing the question a little bit differently. I'm basically doing the same thing, but in reverse. I want to get rid of those columns. Instead of retaining the owner's name, the pet name, the species, and the breed, or I'm sorry, the species and the sex, now I want to, instead of retaining those, I just want to get rid of the breed, the weight, and the height. So again, we take our data frame pets, we're piping it into select, but this time to get rid of those rows and columns, minus breed, minus weight in pounds, and minus height in inches. And it's going to return the exact same data frame. So again, 2 ways to get to the same place. But again, it really depends on whether you're just trying to get rid of some rows and, or I'm sorry, get rid of some columns and variables, or you want to necessarily think about it in terms of retaining them. All right, next up, arrange. So the arrange function lets us reorder our rows based on a variable. Now, by default, arrange is going to arrange in ascending order, which means from small to bigger, right? Ascending, getting bigger. If I want to do descending order, we have two options. We can either use a negative, or I prefer to do arrange descending just because it looks better to me. I look at that code and I'm like, oh, I'm arranging in descending order. I'm going from biggest to smallest. Okay, I'm not missing a negative sign somewhere, right? Because again, right, it's coding, and we've all missed negative signs in math, and well, it's like the same thing. But again, you do have multiple options for pretty much everything you do in this programming language, so just play around with it. But again, let's say I want to arrange the pets in my data frame by their weight in descending order. So I want to do the biggest weight first, and then so on and so forth. So I take my data frame pets, I'm piping it into now my arrange, and inside arrange I want to do descending. I want to do descending based upon the weight in pounds. Now again, notice I got to make sure all my parentheses end up being closed. So because it's arrange, there needs a parentheses. Descending needs a parentheses. So there's two sets of parentheses. Each one has an opened and a closed here for us. And when I do this, well, there we go. Now my data frame is completely rearranged, and we have it rearranged based on the weight column. So if you look at the weight column down there, go from 40, 28, 19, 18, 12. And then again, the rows moved themselves, like the entire row moved. We didn't just move necessarily the weight column, right, and just rearrange that. We arranged every row. Every row was kind of stuck together and moved to where it would be appropriate based upon, again, descending order of the weight. All right, so now that we looked at a couple of these functions, let's say I only want the dogs arranged by weight in descending order. All right, and I'm going to be combining some functions. And again, this is really where we get into the really wrangling part of my data. So I'm going to, again, start with my data frame pets. I am going to pipe that into my functions. And I want only dogs arranged by the weight in descending order. So again, I'm going to filter first. And again, typically we do want to filter first. Let's get rid of any rows we don't want to look at. All right, so I'm going to filter for the species being equal to dog. Then I'm going to pipe that result. All right, so I piped my original data frame in. I filtered for dogs, which gives me a modified data frame. And I'm going to pipe that modified data frame into my arrange function and arrange in descending order based upon weight. And then that will return in the code, well, just the 3 dogs from before, this time arranged in descending order based upon the weight of the dog. And so again, we take our modified data frame and we pipe it. And we pipe it, and we pipe it, and we pipe it. And again, it lets us kind of chain together and combine a bunch of these different functions at once so that we can end up with the final data frame that we really, really want. All right, next up, how do we create something new? If I want to add another variable or another column to my data frame based on our existing variables, we use mutate. Now, we can actually use mutate to also overwrite old columns in our data frame as well. We can absolutely overwrite an entire column using the mutate function, and that is a useful thing to do sometimes. We're not going to see an example of that, but you would just basically set the, well, I'll show you as we do the example. So let's say I want to add a new column or a variable. Again, typically this is done by a mathematical manipulation of one or more of my existing columns to kind of create the new column, or we create some sort of logical comparison where we're going to get you know, like a yes or a no type answer, and then, you know, base it that way. But again, the main idea is we start with our data frame, our generic data frame. I'm going to pipe that in to my mutate and my new column. All right, I'm going to name whatever I want my new column to be, and it's going to be equal to, and then some sort of formula. Now notice, because I'm setting my new column equal to some formula, I am just using a single equal sign. This is not a logical comparison. I'm creating an entire new column that is based upon some formula or some function. And so it's only one equal sign here. And like I said, I get really frustrated with that because I make that mistake all the time. I don't know why. It's just something that I do. We all have our things, right, that we got to be careful for. But that's the idea. Now, like I said, you can also overwrite columns that are already existing in your data frame. So instead of creating a new column, you can just overwrite one of the old ones. If you use the name of a column that already exists, right, if the column already exists in your data frame, and you use that column name inside the mutate function, it's just going to overwrite all the values, and they'll be lost to the random access memory of the world, right? So let's try an example. So let's say I want to create a new column in my data frame which has the pet's weights in kilograms now. So I had it in pounds, now I want it in kilograms. So I'm going to take my pets data frame and I'm going to pipe that into my mutate function. And so my new column, again, I want to be descriptive, so it's going to be the weight in kilograms, so weight underscore kg equals, and so my formula, the way I convert pounds to kilograms is I divide by 2.2. At least I'm just rounding to not many decimal places. That's the easiest way. We can divide by 2.2. And so if I do that now, we can see we've added a new column all the way there on the right-hand side. And that new column on the right-hand side is called, well, weight in kilograms. And, well, we took the weight and we divided it by 2.2, and those are my results. And again, I have my brand new column now in my data frame. And again, once I do that mutate, if I want to get rid of the pounds, get rid of the weight in pounds, of course, I could use what function that we already talked about to remove a column? Yeah, I'm sure you know, right? Or we'll go back in the video and you can check. All right, so let's combine all this together now. I want to take my original data frame. I want to filter only for the large dogs. I want to convert the weight to kilograms, and then I want to exclude the breed, the weight in pounds, and the height in inches, and I want to save this as its own new data frame. Let's bring it all together now, right? So, how am I going to do this? Well, first of all, I got to make sure I set up, well, what's my new data frame going to be, and how am I going to get there? So my new data frame is going to be large dogs. All right, so my new data frame is large dogs. I'm going to create that brand new spot in my computer's memory. I'm going to store in it, I'm going to start with my data frame pets, and that data frame pets is going to be piped into each of my functions now. So the first thing I want to do is filter. Again, typically that is the best idea, is to get rid of the rows and columns first. Take your big data frame and modify it to make it smaller first. Again, it wouldn't make any real difference in this one because we have such a small data frame to begin with. But in general, if you have a huge data frame, make it smaller first before you start to modify or add. All right, because then it'll go much, much quicker because you're working with a smaller modified data frame. So again, typically choose your first function to modify and make smaller if possible. So I'm going to filter for species that equal dog, and the weight is greater than 20 pounds like before. So now I've filtered, I'm selecting only those particular values, or I should say those particular observations. And I'm going to pipe that into my next one, which is to mutate. And again, I'm doing mutate now before I get rid of my columns because, well, I don't want to get rid of the column before I use it in my formula. All right, so again, we want to be really careful that, again, we're kind of thinking ahead. Sure, I can get rid of the rows that don't match, but I don't want to get rid of one of the columns that I'm going to need for my formula to create my new column that I want. So mutate, again, that's my mutate function. I'm creating a new column called the weight in kilograms, which is the weight in pounds divided by 2.2. And I'm taking that result, and now I'm piping that result, again, into my select function, where I'm getting rid of the breed, I'm getting rid of the weight in pounds, and I'm getting rid of the height in inches, and it will result in this modified data frame, where I only have my two observations. There's only two things in my data frame where they were both dogs and larger than 40 pounds. I converted the weight to kilograms and created that column, and then I got rid of the columns that I didn't care about, which were the breed, the weight in pounds, and the height in inches. All right, and again, kind of bringing it all together now. And again, that's the really, really nice part about the piping feature, and that's why we use it so much, is bam, pipe, 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 pipe. Make life way easier. And again, I now have my brand new data frame, which is nice. All right. Now, what if I want to add another row to my data frame? Well, I'm going to use rbind. Now, rbind can add a new row, or we can actually combine data frames and put a data frame on top of a data frame, basically adding the rows to our data frame. If I want to combine data frames and just add the columns, it's going to be, well, called a join, and it's something for like 2 weeks from now. And we'll talk about it then. All right, but for now, we're just going to talk about adding rows to our data frame. So first, typically, if I want to add a row, I want to actually create a brand new vector or a brand new list first. And remember, the way we make a new vector or we make a new list, again, we pick our variable name that we're going to store it under, we store it, and it's the C, and then in parentheses, we have each of our entries separated by a comma. So for this example, let's say I got a new observation. I have my friend Dave, who owns a male bulldog named Jimbo, who is 50 pounds and 14 inches tall. And I want to add that observation to my data frame. Well, the first thing I'm going to need to do is take all that information that was just in that sentence and put it into a list or a vector in the proper order that my data frame already is in. So my data frame, all right, the variables in order in the way it's given, it was owner, pet name, species, breed, sex, weight, and height. All right, which means if I want to create a vector or a list for new pet, I'm going to have to go in order. So new pet being stored, to create the list, C, and then parentheses, and then going in order, Dave, Jimbo, dog, bulldog, male. And again, those are all names. Those are all characters. Those are all strings of characters, so those all go in quotes. 50 pounds, that's a number, no quotes. And 14 inches, no quotes. All right, so that creates my new vector. And like I said, quotes around the names, not the numbers. And then once we have it, we need to bind it to our data frame. And in this case, we want to make sure we, again, save our updated data frame by overwriting the old one. And so pets, stored in pets, because again, I want to just add this new row. I'm still keeping my data frame the same. There's no point, in this case, creating two separate data frames to go back and forth. I'm just trying to add these entries. So I'm going to store in pets. I'm going to take my original data frame pets. I'm going to pipe it into my rbind function and add that new row called, well, new pet that we just created, right? That was the list or the vector we just created. And boom, now we have an extra row in our data frame. All right. So everything I've been doing are outputs. All right, I kind of changed the colors and I really just kept the values. Typically when we do outputs, this is what it's going to look like in the console instead. We're going to see, again, the comment that this is a tibble, which is another name for our data frames in R. We have a tibble. It is 6 by 7. That means that's the dimensions. That is the number of rows by the number of columns. And again, what's nice about this is that we also have the name of each variable. We know how it's stored. So the owner name is stored as characters. So it's the pet names, the species, the breed, and the sex. Those are all stored as characters. The weight in pounds and the height in inches are stored as doubles, which is just another word for really numbers that can have decimal points on them. And again, this is what that data frame is going to look like. Now, the reason I said that is because we also have two last functions we're going to talk about, which are the summarize and the group by function. Now, to create summary statistics, we use summarize or summarize. Either with the Z or the S, depending on if you want to spell it correctly or incorrectly. You can do it either way. So because we live in America, we're going to spell summarize with a Z because we're in America. But again, you can get away with the S. It doesn't really matter, to be honest. Now, one of the nice things is we typically are going to use the summarize feature along with the group by function. So group by is its own separate function where we can take a data frame and actually group items by a particular variable. However, it's not changing the data frame itself. Group by is basically just going to go through and be like, oh, well, how many different groups do we have based on whatever your criteria is? So again, I think an example should help bring it home a little bit better. So if I did group by, and again, my pets data frame, comma, species. So again, my first argument here is the pets data frame. I wanted to do one where I wasn't just piping, right? So again, when we use these functions, we can use the functions by themselves without piping, but the first thing has got to be our data frame itself. So I want to group by, and then my data frame is called pets, and I want to group by the species. All right, the species. So we look at the species, we have cats and dogs, right? So my output, it looks almost exactly the same. I have a tibble. It's 6 by 7, except here is the other part. See that next hashtag or pound symbol or number sign, which means it's kind of being commented out. It's telling me that under the groups, I'm grouping it by species, and there's two species. All right, there's two different values that my species variable takes on. Dogs and cats. I'm not being told that. I'm just being told that there are two groups. So my data frame is unchanged, but now I'm told that there are two groups in there. Okay, which would be, again, the cats and dogs. So the way we use summarize and group by together is that when we combine them together, I can get summary statistics based upon those groups. So if I want to find the average weight for the dogs and the average weight for the cats, I can pipe my results from group by into my summarize function. So I'm going to group by cats and dogs, which again doesn't change anything on the outside to us looking at it, but the computer will know, oh, I'm grouping by those different variables, or grouping by that different variable, I'm sorry, with that, which has different values, and then summarize my statistic based upon that. All right, and again, typically we're going to want to name our summary statistic as well. Again, a good idea to kind of save it because our output is going to be a data frame again. Don't forget, right? Every output is a data frame. Every input is a data frame. We modify it somehow, and then we're going to get an output of a data frame as well. So in this case, I'm going to take my pet's data frame. I'm going to pipe it in. I want to group it by species. So again, right, we know the species were either cats or dogs. So I'm going to group it by species, and then I'm going to take that result and pipe it in. So I had the computer check. It's going to group by the species. It's not going to change the data frame at all. It's just kind of doing it in the background. There's two species, cats, dogs. And when I pipe it in, I want to summarize. Now again, like I said, it's a good idea that we make sure we name it, because when we output a data frame, and when we name it, it's going to give that data frame column a name, and it's going to tell us, again, what that data frame is when we try to use it later. So I want to summarize. I want to say the weight, and the weight equals the mean of the weight in pounds. All right. And when I run this code, what I'm going to get is a tibble, a 2x2 tibble. And again, it's grouped by the species. There's only two species, which means there's only two observations. All right. There's only two observations here, cats and dogs. And then I have another column for the weight, and the weight is the average of each of the weights of the cats or each of the weights of the dogs. So again, it took the two cats, I think it was. I think there were two cats, averaged those two cats' weights and got 15. There were 3 dogs, or maybe 4 dogs. Now I'm forgetting how many there were. But the average of the dogs' weights and got 34.2. And again, it summarized those and separated for us. And that's how we use the summarize and group by functions together. All right. I know this was a long one, longer than usual. So, can you answer the following questions? And if not, well, go back and look at it. Question number 1. What function would you use if I wanted to remove columns from my data frame? What function would I use? Question 2. How would I save our modified data frames? And again, this could be kind of a two-part. How could I save it in a new place in the physical memory? Or how could I save it in the same place in the physical memory? How do I save those results of my modified data frame? And then question number 3, and this one's a little bit more specific. Pet BMI is found by dividing its weight in pounds by its height in inches. How would I create a new column in my data frame that displays each pet BMI? So if I wanted to create a new column for BMI, then I want to make sure I name that column too, and the result, right, the way I find BMI is dividing the weight by the height. How would I create that new column? All right. So, again, I know that was probably a lot. Take your time. Hopefully you took some notes. Pause the video as you need to. Go back as you need to. And, get used to these basic tools that we're going to be using for wrangling our data. And as always, take care of yourselves.